Hey, this is 8-9, remembering properties of powers and roots. I've got them down there in the tables. Go ahead, just memorize those. Great, got it? Okay, good. Uh, Now that you've got that, let's look at some ideas for when you forget. One of the ways to deal with this is by using special cases. If you can't remember exactly how it works, then try a special case and see if it does work. You want to be careful, though, of choosing special cases that might work for that one case but may not work in another one. So you might want to check a couple of things to be sure. If it doesn't work some way in one special case, then it's not going to work. So properties of square roots and properties of powers. We've gone through all of this. You should know what all of these are about. Let's get on with the lesson. Okay, example 1. Mark was not sure how to simplify x to the 23rd raised to the 6th power. He felt that the answer could be x to the 138th or x to the 29th, which is correct. Now you just looked at properties, so you probably know which one to use here, but let's say we've forgotten and look at some ways to check it. Now in checking a special case, it's clear that putting in 0 isn't going to help us learn anything. If we put in 1, that won't help us either, because both of those will equal 1, x to the 138th or x to the 29th. So let's try 2, because there's no point making it incredibly hard. So what we want to find out is 2 to the 23rd power raised to the 6th power. Does that equal 2 to the 138th or 2 to the 29th? We can just do the math and see what we get. So 2 raised to the 23rd power and that raised to the 6th power is a very big number. 3.484 and so on times 10 to the 41st. So that's what this one equals. So let's just raise 2 to the 138th. And 2 to the 138th power is 3.484 times 10 to the 41st. There we go. We found that the correct answer is x to the 138th is the right way to go. And that's by using a special case to determine the right solution to the problem. Example 2, take a look at this problem and you'll notice that 2 squared plus 2 squared equals 2 cubed, because 4 plus 4 equals 8 and 2 cubed equals 8, and that 0 squared plus 0 squared equals 0 cubed. Can you conclude that x squared plus x squared equals x cubed? Well, if you were to do this, what you want to do is to check another special case. You've got one case here, you've got another one with zeros, which is always a little suspect. So let's just try another number. How about if we go with 4 squared, so if we choose 4, we've got 4 squared plus 4 squared, and does that equal 4 cubed? That'd be 16 plus 16. And does that equal, let's see, 4 raised to the 3rd power is, the math there, what? 4 raised to the 3rd power equals, so 4 thirds is 64, and 16 plus 16 is 32, which does not equal 64. does not equal. We cannot conclude this because we have one special case that shows it's wrong. That's all we need to demonstrate that it's wrong. So the property is not always true. Okay, example 3. Using the radii from the example 3 in the text, that's on page 513, find the ratio of the surface area of Earth to the surface area of Jupiter. The mean radius of the Earth is given, as well as the mean radius of Jupiter, and for surface area we use that 4 pi times r squared is the surface area. So 4 pi times 3.96 times 10 to the third squared over 4 times pi times 4.34 times 10 to the fourth squared. The 4 pi cancels. 4 pi over 4 pi is just that. Because these are both squared, I can use my properties to rewrite this all within one fraction bar. I have 3.96 times 10 to the third over 4.34 times 10 to the fourth. This whole thing squared. I have these powers are the same base. I subtract 4 from 3, I get a -1, which means I just have a 10 here, so I can cancel out those 10, that 10 to the third. I have 3.96, and this is divided by 4.34 times 10, which would be 43.4. That whole thing will be squared. So I'm going to take my result and square it, and that'll give me the ratio in the surface areas between Earth and Jupiter. So let's see, 3.96 divided by 43.4 equals, okay, and we square this. And I get about 0.008 to 1 is the ratio of surface areas between the Earth and Jupiter. Okay, one more example to go through. This is the guided example on page 513 is where it begins, and it asks you to determine if 9q to the -5th power over 6q to the -3rd, that whole thing raised to the -7th, equals a times q to the n. What are the values of a and n? Then this breaks this down for you. This question requires that the expression on the left side be simplified into the form of aq to the n, which means I need to use properties to eliminate parentheses and create a new equation. So this would be 9 to the what power? -7th power. This is going to be a -5 times a -7 is going to be the 35th power. 6 will be to the -7th power. And q is a -3 times a -7 will be 21, the 21st power. So I want to apply the quotient of powers property. This is still 9 to the negative 7th because these bases are different, but the base for q is the same. So I subtract 21 from 35 and I get q to the 14th power. Now I apply the negative exponent property, which allows me to flip this because the negative 7 meant that it goes into the numerator. For the 6, the negative raised to the negative 7th power means it goes to the numerator. For the 9, the negative 7 power means it goes to the denominator. And so this would be 6 over 9 raised to the 7th power, q to the 14th power. 6/9 reduces to 2/3 to the 7th power, still q to the 14th power. So a is equal to 2/3 to the 7th power, and n is equal to 14. Okay, that's it. That's our application of properties. Get prepared. You got a test coming up. Best of luck on it. I'll see you in class.